This is lesson 10 from the using units of measurement topic, and this lesson will be looking into finding areas of shapes. The learning goal for this one is to look into the areas of rectangles, triangles, and parallelograms. And the success criteria is to be able to establish the formulas for areas of rectangles, triangles, and parallelograms, and use these in problem solving. So we've already looked into areas of squares and rectangles and triangles. We'll be also looking into the areas of parallelograms, which is eerily similar to rectangles and pretty much uses the same type of format as the area of a rectangle. This one here, we're going to look for the area of this rectangle. And remember, the area of any rectangular or square shape is just length times width. Give me a length, which is 5. Give me a width, which is 12. And I can give you the area, which is 60. Now it's 60 meters because we're using a meter units. And we need that little 2 there to indicate that we're working with a 2-dimensional shape, or we're getting the area of a 2-dimensional shape. So we're looking for 60 squared meters. So it can't be this one because it's centimeters, it can't be this one because it's centimeters, and it can't be this one because there's no little 2 there. So it has to be this answer here. So be careful when you're looking for area, you're using squared meters. And volume is cubic meters, so there's a little 3 in there, but in this case it's just area, so it's squared meters. Now the area of a parallelogram, it follows the same format as a rectangle. The only letters that are different is L and W. We use B and H, where B is our base and H is our height. And again, we want to be specific, and you'll always hear me say this, it's perpendicular height. Perpendicular height. This just means that whatever the base is at a 90-degree angle of what the base length is, we need to get the height. We don't want to get this length here, because again, this is considered the slant. This is the slant, and we don't want to use a slant within our measurement of getting the area. We have to use the perpendicular height. And in this case, it's very simple. Our base is 4, our perpendicular height is 11, so our area in this case is 44 squared meters. So there's our answer here. The area of a triangle, if you remember from the previous videos, it's half times base times height. And that half just comes from that a triangle, any triangle is always half the size of a rectangle. We know what our base is, and we know what our height is, and we can just plug this into our calculator. 1/2 times 8 times 12. And this will give us 48 squared meters. So that's our answer right there. Now this parallelogram, which parallelogram has an area of 42 squared meters, we're looking for one of these 4 that when you do the base times the height will give us 42. So 8 times 5, this will give us 40. So it can't be this one. 6 times 7 is 42. So this could be the one, and I'll just double check. 9 times 6, 54, and 6 times 6, 36. So this one here has to be our area. So these up questions are really simple because you're just filtering through which one is the correct one, just making sure that you use the correct formula for either rectangle, parallelogram, which is effectively the same type of formula, more importantly the triangle one. You gotta be careful with the triangle one. And the last example here, this is kind of throwing you into the deep end because this is actually quite a tricky example here. If the area of this red wall is 24 squared meters, what is the unknown side length here? So we've got 3 side lengths. We know that our base here is 4, and the height from the top or the bottom of the roof to the top of the roof is 2 meters, and what we're looking for is this length, this random length here. So how we tackle this is we break this up into 2 pieces. There's a triangle, and then there's also a rectangle. And this will give us some better insight into how we can break this up and get as much information as we can. So this is 4 meters. This is the thing here that we're looking for. This here is 2 meters, this perpendicular height. What is this length here? Well, if this is 4 meters, it's going to be 4 meters consistently throughout. So we know that this also has to be 4 meters. And we know the area of a triangle. The area of a triangle is just half times base times height. So this is half times whatever our base is, 4, times whatever our height is, which is 2. And when you pop this into the calculator, you'll end up getting 4 squared meters. So we know that this is 4 square meters. And what we're trying to look for now is, well, what could this area be? Because once we know what this area is, we can determine what the side length is. Well, the area of the full thing, so this plus this, is 24. And we've already worked out that this area here is 4. So if this area here is 4 squared meters, and the whole thing is 24, 24 minus 4 is 20 square meters. So this thing in here has to be 20 squared meters. And now that we know this, our area is equal to length times width. But we already know that the area is 20. This 20 is equal to length 4 times some number. And there's only a number that when multiplied by 4 will give me 20, and that's 5. So my height has to be 5 meters. It's the only number that can work, as 4 times 5 will give me 20. That 20 will be the 20 inside here. And this will be 4 from the base times height. 20 plus 4 will give us that 24 squared meters there. And that's it for this skill. This is the second last skill. 20 questions to do. See how you go, and I'll see you in the next and potentially last video. Bye bye.